Good morning, student. Today we start rest part of the determinant. In previous lecture we discussed about the solution of system of linear equation by matrix method, and we taken an example on this concept. Now we taken another types of example which basis on this concept. Another example is that so that the following system of equation is consistent. Equations are given 2x minus y plus 3z equals to 5. Next 3x plus 2y minus z equals to 7, and 4x plus 5y minus 5y minus 5z equals to 9, and also find solution. So there are two parts of the question. In first question, first we identify that this system of equation consistent or not consistent. After that, if these equations are consistent, then we want to find the solution of equations. Now we find also, now for system we start, first we write the matrix form of given these equations. So this will be the 2 3 4 minus 1 2 5 3 minus 7 minus 5, next x y z equals to 5 7 9. So here this is a dot x equals to b. So this we write a into x, matrix x equals to b. This is x and this is matrix b. Now we find the determinant of matrix A. So this will be 2 3 4 minus 1 2 5 3 minus 7 minus 5, and value of this, for determine the value of this, we expand this in with respect to any row or column. We respect this with respect to R1, so we get this will be 2. For 2 we cancel out all elements with respect to our perpendicular lines which passes through point 2. So this will be this. So here will be minus 10 plus 35, this will be plus 1 next. So this will be minus 15 plus 28 next 3, with respect to 3 this will be 15 minus 8. So we see here this will be the 25 which equals to 50, and next this will be the 28 13, and next this will be the 7 plus 21. So this so with this find out that determinant of these equations will be 0 or not. First of all we check that this equation will be 0 or not. Here we have to given equations 2x minus y plus 3z equals to 5, next 3x plus 2y minus z, this is minus z equals to 7, and next 4x plus 5 minus 5y plus 5z equals to 9. So we find the determinant of A. When we write these equation in matrix form, so equation will be 2 3 4 2 3 4, next will be 1 2 5, and next 3 minus 1, here will be minus 1. So this is the mistakes of questions. So we solve this again, this is minus 1. Now when we taken this, when we taken with respect to 2 minor matrix will be minus 10 plus 5, and next will be minus 15 plus 4, and with respect to 3 this will be 15 minus 8. So answer will be, this will be minus 5, so here will be minus 10 and this will be minus 11 and this will be 7 into 3 21. So answer will be 0. Here we watch that since mod of A equals to 0, mod of A equals to 0. So now we find the adjoint of A. After that check that A dot adjoint A into A equals to 0 or not. After that this will be after that this we define the solution of this. Now find adjoint A, and we know that the adjoint A is the cofactor matrix, transpose of cofactor matrix of A. So we find this by short method, which always explained in previous lesson. Now we taken an example adjoint A. So this is the transpose matrix of cofactor matrix of A. So with respect to 2, cofactor matrix will be 2 minus 1, 5 minus 5. With respect to minus 1, this will be 3, 4 minus 1 minus 5. With respect to 3, this will be 3, 4, 2, 5. And with respect to 3, we taken minus 1, 3, 5 minus 5. And with respect to 2, this will be 2, 3, 4, 5 minus 5. And with respect to minus 1, it will be 2 minus 1, 4, 5. And with respect to 4, this will be minus 1, 3, 2 minus 1. With respect to 5, this will be 2, 3, 3 minus 1, 2, 3, 3 minus 1. And with respect to minus 5, this will be 2 minus 1, 3, 2. Now we take in plus minus, plus minus, plus minus, plus minus, plus minus, plus and dash of this matrix. So after solve this matrix, we find minus 10 plus 5, this will be minus 5, minus 15 plus 4 equals to minus 11. So this will be plus 11. Here will be 15 minus 8, 7. Next 5 minus 15 equals to minus 10, which is also plus 10. This will be minus 10 minus 12. So minus 22. Now 2 into 10, 10. 2 into 5 into 10 plus 4, 14. This will be minus 14. Here will be 1 minus 6 minus 5. Here 2 minus 9 minus 11 means this will be plus 11. Now here 4 plus 3, 7. Now we find transpose of this. So this will be minus 5, 11, 7, 10 minus 20, minus 14, minus 5, 11, 7. So this is the transpose, this is the adjoint matrix of A. Now we find adjoint A into matrix B. So adjoint matrix we have to given minus 5, 10, minus 5, 11, minus 22, 11 and 7 minus 14, 7. And here B is a matrix equals to 5, 7, 9. So this is the order of 3 cross 3 and this is order of 3 cross 1. So we multiplied both these two matrices like this, row and columns. When we multiplied this will be equals to a matrix of 3 cross 1 order. So this row multiplied to this column, corresponding elements we taken. 5 minus 5, this will be minus 25. Here will be 70. Here will be 49. Sorry, 45. Now when we take in this 55, this will be the minus 154 and this will be 99. Now next we take in 35, this will be 98 and this will be the 63. So we after solve find the answer which also equals to 0 matrix. So we know that if A dot adjoint A into B equals to 0, then solution of given system of equation will be infinite. So solution will be infinite. If this does not equal to 0, then equation does not consist, means solution of these equations will be not possible. Now we start next steps. So we say here solution will be infinite means equation will be consistent. Now for infinite solution as previous, we suppose that a variable z equals to k, putting in first two equations, putting z equals to k in equation 1 and 2 we get. So this will be 2x minus y equals to, here we when put k, then k minus 5 minus 3k, and next will be 3x plus 2y equals to 7 plus k. Now here we write these in matrix form. After that we find 2 3 minus 1 2 and this will be x y equals to 5 minus 3k 7 plus k. This is the matrix form, and also we again suppose this Ax equals to B or A1 B1. Since AB also repeat in this question, so we suppose this A1 B1, where mod of A1 equals to 2 3 minus 1 2, here will be 7 which does not equals to 0. So solution will be possible. Now we find adjoint A1. So adjoint A1 means cofactor matrix of transpose of cofactor matrix A1. So transpose of A1 here will be with respect to 2, this will be 2, with respect to minus 1 here is 3, with respect to 3 here is minus 1, and with respect to 2 here will be 2, and taking plus minus minus also, and after that plus. So this will be 2 minus 3 and here will be 1 2. So we take in, now with this suppose equation as 4, now we find A inverse, A1 inverse. A1 inverse means adjoint A1 upon determinant A1. So this will be 1 by 7 2 1 minus 3 2. So by equation 4 we know that x will be A1 inverse B1. So here will be 1 by 7 2 1 minus 3 2, and next is here 5 minus 3k and 7 plus k. This is order of 2 cross 2 and this is order of 2 cross 1. So answer will be also as 2 cross 1. So we multiplied these, we find that 10 minus 5 into 2 10 minus 6k plus 7 plus k upon 7, and next will be minus 15 plus 9k plus 7k, sorry, this will be the 2 into 7 means 14 plus 2k upon 7. Now we see again these are the 2 1 are individual elements, and 5 minus 3k is the single element, next is 7 plus 2. So 2 1 multiplied to this and this, after that we add 2 when multiplied to this will be the 10 minus 6k, this will be the 10 minus 6k, and 1 multiplied to this, then 7 plus k and upon 7. After that this also multiplied to this will be the 15, and next will be this will be minus 3 and this will be plus 9. After that multiplied to this minus 21, 2 into 7 14, after that this will be 2k upon 7. So, this will be the here will be 17 minus 5k upon 7, and next will be the 11k minus 1 upon 7. This is the value of x. X means here will be x comma y. So, we find x equals to 17 upon minus 5k, 17 minus 5k upon 7, y equals to 11k minus 1 upon 7, and z equals to k. These are the solution of given equations for real value of k, where k is a real value. And put differ value of k, we find the differ infinite solution of x, y, z. So, this is the final answer of given equations. Now, next we discuss about some questions related to determinant, which are very important regarding boards exams. These questions are based on the property of determinant, and to solve these questions we always remember given 8 properties which are related to determinants. Always remember. First question we have to given that prove that alpha is square alpha cube, alpha is square beta gamma. Next column will be beta is square gamma plus alpha. This is gamma is square and alpha plus beta equals to alpha minus beta, beta minus gamma, gamma minus alpha into alpha plus beta plus gamma. Now, we want to this answer. These types of question are very important and very easy also. Since we have to given both parts of the questions, means we have to given question also and we have to given answer also. So, something hints we find from the answer of these. We taken always given determinant as delta alpha beta gamma, alpha is square beta is square gamma is square, beta plus gamma, gamma plus alpha, alpha plus beta. We have to given this determinant and denoted by delta. Now, after applying using property of determinant, we want to find this, not explain this. So, there are some useful property. First property which are very useful of determinant, that if any row or columns, if all elements of a row or columns are zeros, then determinant also equals to 0. Second thing, that when we have to take in common from a row or column, then this common will be outside of the determinant. Means if we multiply to any determinant by a constant, then this will be multiplied only in a row or a columns. And second thing, to prove any parts of the question, first our motto is that we want to create maximum zeros in row or a columns. So, we start here and using the property of determinants. Now, we have to given this and we want to this as the answer, and this is the hint for us that we want to alpha minus beta, beta minus gamma. Alpha minus beta means here is alpha and here is beta. This is the element of a common and column C1, and this is the element of column C2. So, first we apply operations. C1 change to C1 minus C2, and next C2 change to C2 minus C3. And you also remember another thing, that if we have to given order 3 determinants, then we use at a time only 2 operations. Means when we have to given a determinant of order n, then at a time we have used only n minus 1 operations. And to prove the value of determinant, we also use row and column both operation at a time. Now see here, we find that alpha minus beta, alpha square minus beta, and here we will subtract, then this will be minus plus beta, and this will be beta minus gamma. Here beta square minus gamma square. Here when we subtract this, then beta plus gamma, and next gamma square alpha plus beta. Now first we see here we want to alpha minus beta and beta minus gamma. So this column can be written as alpha minus beta into alpha plus beta, and here if we taken, this will be alpha minus beta, beta minus gamma, beta plus gamma, and taking minus common, then beta minus gamma. Here gamma square alpha plus beta. Now we taken alpha minus beta and beta minus gamma. Here all terms containing alpha minus beta, so we taking alpha minus beta common from C1 and beta minus gamma from C2. So next part will be present 1 alpha plus beta minus 1 beta plus gamma minus 1 gamma square alpha plus beta. Now again we produce maximum 0 in this part, so we all again apply C1 change to C1 minus C2. Here will be these two parts as above. So C1 minus C2 means this will be 0. Subtract this, then beta will be cancelled, gamma minus alpha, and this will be 0. Here will be 1 beta plus gamma minus 1 gamma square alpha plus beta. After that, in this column maximum zeros are produced, so we expanding with respect to C1, we get alpha minus beta, beta minus gamma, and in next step this will be alpha minus gamma. With respect to this, answer will be here will be 0 with respect to 0, answer will be 0 with respect to this. Now write all terms with respect to 0, this will be all 0. After that, minus alpha minus beta minus gamma, we taken minor matrix 1 gamma minus 1 alpha plus beta, and next will be also 0. So here will be minus alpha minus beta, beta minus gamma, so this will be gamma minus alpha, and this will be also alpha plus beta plus gamma. This is the required answer. So again we discuss about this question. In these types of question, we first check the answer, what we have to want. From answer we guess that what we apply the operations and what we applied the operation, and our main motto is that using the property of determinant and produce maximum zeros in any row or a columns. Here we produce maximum 0, here is 2 0, so we expand after at last with respect to that row or columns which containing maximum 0. So answer will be very easy. In this way we also find the solution of given determinants. Now next question we have to take in again. Here we have to given that prove that A, B, C, A square, B A square, B square, C square. Next BC, CA, AB. And answer we have to require A minus B, B minus C, C minus A, AB plus BC plus CA, which is as above. Here we have to given these types. So first we have to require A minus B, B minus C, C minus B, A. So we also change C1 change to C1 minus C2 and C2 change to C2 minus C3, and we find the value of determinant like this. This will be A minus B, here will be A square minus B square, here will be minus C common, this minus this, then this will be A minus B. Here will be B minus C, B square minus C square, here we taken minus C, so this will be B minus C, C square AB. Now, we see here A minus B, A minus B, A minus B will be common from this, so this will be A minus B, and here B minus C will be common. So this will be 1 A plus B minus C, this will be 1 B plus C minus A, C square A B. Now, we produce maximum 0, so we again subtract, change C1 as C1 minus C2. So these will be as above, and now subtract C2 from C1, this will be 0, this will be A minus C, this will be A minus C, 1 B plus C minus A, C square AB. Now taking A minus B, B minus C and A minus C, this will be the A minus C. So here will be 1, 0, 1, 1, 1 B plus C minus A, C square AB. Now we applying, here will be 1 and 1, so we change R2 as R2 minus R3. So these above factors will be as, and here will be 0, 1 C, this will be 0, this will be A plus B plus C, C square minus AB, and 1 minus A, AB also. So C1 contain maximum 0, so we expanding with respect to C1, we get A minus B, B minus C, A minus C. With respect to this, we expand when, then answer will be 1 C, A plus B plus C, C square minus AB. After solve this, we find A minus B, B minus C, C minus A, sorry, this is A minus C. And after multiply this will be C square minus AB minus AC minus BC minus C square. So these will be cancel out and taking minus common, and factor will be change A minus B, B minus C, C minus A, AB plus BC plus CA. So this is the required answer. Now we taken another example which is related to also on the concept of this. Before taking another example, we again discuss that these are the main factor, main important points that we produce maximum zeros, maximum zero in a row or a column by applying the properties of determinant and find the solution of determinants. That's okay.